You ever see a pattern that's just so clear, so obvious that you think, that has to mean something? Like a lucky streak at a game or a weird coincidence that feels like fate. Well, what if I told you that your brain, which is this brilliant pattern-finding machine, actually gets it completely wrong a lot of the time? Today, we're going to pull back the curtain on this powerful mental glitch that makes us see meaning where there's only random chance. Okay, so let's just dive right in with a real-world medical mystery. Researchers were looking at kidney cancer rates across, get this, over 3,000 counties in the US. And they found something that at first glance seemed, well, really, really significant. So, what's your first thought here? Your brain probably jumps to a story, right? Something logical. Maybe it's the clean country air, less pollution, fresh food, people are more active. It just makes perfect sense. But hold on to that thought, because the study also found this. Wait, what? Suddenly, that nice, clean story we just came up with completely falls apart. How in the world can a rural lifestyle explain both the lowest and the highest cancer rates? Now your brain is scrambling, trying to write a brand new story. Maybe it's about poverty in those areas, or poor diet, or maybe a lack of access to good healthcare. And this shows the problem perfectly. We've got two plausible, yet totally contradictory explanations. Our brain's fast, automatic system is just desperate to find a cause for what it's seeing. But here's the thing. Both of these stories can't be true at the same time. The real answer? Well, it's something else entirely. So, let's pull back the curtain on this little statistical illusion. The truth behind this whole kidney cancer puzzle is actually surprisingly simple, and it has absolutely nothing to do with diet or lifestyle or any of the stories we just told. The key factor wasn't any of that. It was simply that these counties had really small populations. You see, in any small sample group, you're statistically way more likely to see extreme results, both really high and really low, than you are in a large group. It's just a quirk of math, not medicine. And this phenomenon actually has a name. It's called the law of small numbers. It's this deep-seated cognitive bias where we take a small handful of examples and act as if they tell the entire story. We see an outlier, and our brain just screams pattern when it should really be whispering, it's probably just randomness. So why is this statistical trick so good at fooling us? Well, the answer is a mix of some pretty simple probability and some really old wiring deep inside our brains. Let's make this crystal clear. Imagine a giant jar, and it's filled with an equal number of red and white marbles, 50-50. Now, if you reach in and pull out just a small handful, what do you think the chances are that you get an extreme result, like all red or all white? Now check this out, this is what's so wild. If you draw just 4 marbles, getting an all red or all white sample happens about 1 in every 8 tries. That's actually pretty common. But just up that to 7 marbles, and look how the probability plummets. It becomes rare. And by the time you get to 20 marbles, it's practically impossible. Small samples allow for these crazy swings. Large samples always smooth things out and get closer to the real average. Those small rural counties, they were like drawing only 4 marbles. So the math is clear, right? But our brains didn't evolve to be natural statisticians. Nope. We evolved to survive by spotting patterns. A rustle in the grass might be a predator, so it pays to assume it's a pattern. That instinct served us really well out on the savannah, but it totally backfires when we try to apply it to random data. We end up seeing a cause where there's only chance. Let me show you what I mean. Okay, imagine you're at a hospital, just watching the births. G is for girl, B is for boy. The first sequence of 6 births you happen to see is girl, boy, 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 boy. Okay, seems plausible enough, right? Now here's the second sequence. Girl, boy, boy, girl, boy, girl. To a lot of us, this one feels a little more random, maybe even more likely to happen than that first one. And finally, you see this sequence, 6 girls in a row. Our brain immediately flags this one. It feels special. It doesn't feel random at all. It feels like something must be going on here. So just take a second. Go with your gut feeling. Which one of these 3 sequences seems the most probable? 1, 2, or 3? And the completely mind-bending answer is, they all have the exact same probability of happening. Any specific sequence of 6 births has a 1 out of 64 chance. But our brains just refuse to believe that. A sequence like 6 girls in a row just screams for an explanation, creating what psychologists call the illusion of pattern. So now that you know about this illusion, I guarantee you are going to start seeing it absolutely everywhere. It's not just in some obscure medical statistics. It is deeply woven into how we judge performance in our daily lives. We've all seen it. A basketball player hits a few shots in a row, and we say they have a hot hand. An investor makes 3 good trades, and suddenly they have great instinct. A CEO has a couple of good quarters, and they're hailed as a genius. In every single one of these cases, we're taking a tiny little sample of data and we're rushing to assign a cause, usually skill, when a lot of the time it's just statistical noise. Okay, so our brains are clearly wired to get this wrong. But here's the good news. We are not doomed to be fooled by this forever. You can actually train yourself to spot this bias and start making much, much smarter judgments. The key is to just recognize that feeling, that aha moment, when a pattern seems to just pop out at you. When you feel that, that's your signal to just pause. Don't let your fast, automatic brain jump to a conclusion. You have to intentionally engage your slower, more logical brain. Here is a super simple 2-step process you can use. First, just notice when you're being drawn in by some extreme result or a really compelling story. Then, step 2 is to immediately ask yourself one single, powerful, clarifying question. What is the sample size? Is this conclusion I'm about to make based on 3 good trades or 300? Is it based on one tiny little county or the data for the entire country? Just by asking this one simple question, you can break the illusion of the pattern and protect yourself from the powerful but often very misleading law of small numbers.